Okay, so structure of an atom. I'm going to combine a couple things. This is not a part that you necessarily have a worksheet on, but I wanted you to, I'm going to talk about this a little bit before we go into ionic bonding. So this is the structure of an atom. We've talked about this before, but I'm still going to bring it back up again as you get into bonding. You kind of need to go back over this. So an atom consists of a nucleus, which is a central core surrounded by protons, which are positively charged, electrons, negatively charged, and then neutrons, no charge. The charges balance out because you have an equal amount of positive and negative charges. Okay, so if you have 6 protons, you have 6 electrons. If you have 4 protons, you have 4 electrons. They balance each other out for neutral atoms, okay? These are the models. The modern atomic model looks like this. It's gone from what I learned back in the late 90s to what we have right here, this cloud, versus a model here which includes the cloud and then the nucleus, which shows positive and neutral particles in it. But this idea was still around because we have these different levels of electrons, and we're going to talk about those different levels. But it's more of a cloud now that we show them in rather than in a two-dimensional model. But the same basic idea that there are specific amounts of electrons in each level as they go out from the nucleus. That's still a very prudent thing to know, but we just need to know that it's more of a three-dimensional model. Okay, so that's your basic structure of an atom. Okay, so most of the mass is going to be in the nucleus. In fact, it's a really tiny mass, but it's still where the mass of the atom is. Protons weigh like 20 times as much or more than that, hundreds of times more than an electron does. And same with neutrons, they weigh about the same. But they are, so much larger than the electrons. And then most of the volume is going to be taken up by that cloud of electrons. In the book, if you didn't read this, which you probably didn't, I didn't make you read it, but on page 52, I think this is always kind of interesting to talk about. The atom's volume is the space in which the electrons move. The space is huge compared to the space occupied by the nucleus. So if you think about it, the pitcher's mound in the baseball stadium, in a huge baseball stadium right now, okay, so we talk about the pitcher's mound, that's where you'd find the nucleus. Whereas some of the electrons can be as far away as the top row of seats. If we're looking at this, obviously this is not how big an electron or how big an atom is, but if we blow it up and think about the amount of space occupied compared to the nucleus and where the electrons are, that is how far, that's how much volume it can take up compared to where the nucleus is located. So pretty amazing stuff for something so teeny tiny. Okay, so I mentioned this before when we were talking about the periodic table. Now it comes back into play here. We're going to start talking about bonding. Bonding happens with these things called valence electrons. Valence electrons are those that are found furthest from the nucleus, and they are the ones involved in bonding. Those are the ones I talked about where you want to have 8. 8 is the magic number of valence electrons that you want, because if you have 8, you don't want to bond. So if you're involved in something that has makes your number 8, you don't need to bond with anything else. You are bonded. Or if you have 8 yourself, you are happy, which is why the noble gases don't bond, because they have 8 bonding electrons and they're full. They don't need to bond with something else. They use these things called electron dot diagrams to show the number of valence electrons. So right here, they're just showing you, these are electron dot diagrams. Hydrogen has 1, which means that it can bond, it wants 7 more, or it wants to give up 1 and form a bond with something. Carbon has 4, which usually that means it's going to share. We're going to talk about covalent bonding as well. And then oxygen here, that has 6, which means it's going to bond with something that is going to pick up 2. It's going to form a bond that way. So those are your these are just examples of electron dot diagrams, which show the valence electrons in an atom. Okay, so like I mentioned before, the number of valence electrons is 8 that you want. Bonds formed when valence electrons are either they should be transferred or shared. And so we're going to talk about ionic bonding first, which means they're transferred. And then we're going to talk about these things called covalent bonds, which means they're shared. So we'll start with ionic bonds and in this section, which talks about how they are transferred. Okay, so we're going to jump right into ionic bonds, which is the, let's see, I think it's the 3rd section in chapter 2. I don't have us go over the periodic table again, which is the 2nd section in chapter 2. And I took a little bit out of section 1 just to talk about valence electrons. But this is the 3rd section, which is called ionic bonds. Okay, so an ion is an atom with an electrical charge. We just talked about how they're neutral. Well, they do have an electrical charge because they can either gain or lose electrons when they bond, or when they want to bond, I should say. So a positive ion is an atom that loses an electron. A negative ion is one that gains an electron. So that means that it wants some valence electrons or it wants to lose some valence electrons. Valence electrons are the ones that are involved in bonding. So when it wants to lose one if it has probably like 3, 2, or 1 in that outer shell, and it wants to gain if it has like 6, 7, 5, 6, or 7. 5 maybe not so much, but for definitely 6 or 7, they're going to want to gain some electrons. So they're looking to pick something up. If they gain those electrons, if they take them from something, that means they gain a negative charge because they have more electrons than protons. If they give them up to something, that means that they're losing electrons, which means they are gaining a positive charge. Okay, that's the whole basis behind all of this. So they're showing here in this little cartoon here. So it says, I'm about to lose an electron. Are you sure? I'm positive, because if he lost an electron, that means he has less electrons than protons, which means he now has a positive charge. Okay, so that's how that works. So now that they've got charge, they've lost an electron or gained an electron, they've gained charges. That's how a bond will form. Okay, so ionic bonds are formed between these two oppositely charged ions. So once they give up an electron or gain an electron, they gain a charge. And guess what? Opposite charges attract each other, and these opposite charges cause bonds to form. So compounds that are electrically neutral, because these ions come together and balance the charges of electrons. So ionic bonds are these attractions between these charged ions that are created when valence electrons are lost or gained. So if they gain them, valence electrons, they gain a negative charge. If they lose them, they gain a positive charge. Opposite charges attract, which means now I form a bond. It's called an ionic bond. So here we're showing down here, we've got sodium and we've got chlorine. Sodium has 1 valence electron. Remember, it's an alkali metal. It wants to lose its electron. Then we have chlorine, which has 7. Halogen wants to gain an electron. Look at that. We throw this over here right here. So this one gives it up to the chlorine, and now this one's got 8. But guess what? It's got an extra negative charge, which means it's got a negative charge. And now it's lost an electron, so it's got more protons, which means that has a positive charge. Positive, negative attract. You've got table salt, so sodium chloride. Polyatomic ions are ions that basically are made of more than one atom. I don't know why I said more than one ion, but more than one atom. So here's a list of some ions here, but there's also got some polyatomic ions in here as well. So for instance, bicarbonate is a polyatomic ion. Ammonia is a polyatomic ion. Carbonate, sulfate, phosphate, all of these are polyatomic, which means that they are bonded. They form an electrically neutral bond, but they have some valence electrons to share, so they have an overall charge to them. So once they form their compound, they have a charge, which means they have like 3 extra electrons, or they have 2 extra electrons. So depending on their charge here, this means I'd have 2 extra electrons. If I don't have that, if like for chloride, I just have 1 because there's nothing next to it. Positive 2 means I have 2 extra protons. So something like this 2 extra protons would very easily go with this carbonate here. So calcium carbonate. Calcium carbonate is formed when calcium goes with the carbonate here, which means that now it's an electrically neutral compound. So charges balance each other. For every single compound, balances charge. You want charges to balance, just like when we were talking about balancing chemical equations, charges balance as well for ionic compounds. Okay, so ionic compounds are named first with the positive ion and then with the second with the negative ion. So the first name of the compound is always going to be your positive ion. Second is always going to be your negative ion. Okay, so when we talk about naming them, which is part of, I think, what I asked you in the worksheet, positive comes first, negative comes second. Okay, some different properties of ionic compounds. So these compounds, once they're formed, they have specific properties about them, just like when we talk about covalent bonded, they're going to have specific properties as well. So the characteristics of ionic compounds are things like a crystal shape, so they're orderly. Okay, so something like a salt crystal. Salt is a ionic compound, and it has a very crystal shape to it, so it's very orderly. It has a high melting point because of that, so because it's got such orderly shape to it, it takes a lot to break those bonds and melt them down. They're also electrically conductive. If you dissolve them in water, they conduct electricity. So they have a crystal shape, high melting points, and they are electrically conductive in water. So those are the 3 main properties of ionic compounds. All right, so putting these 2 things together, these both kind of go on to section 2.3, which is on ionic bonding. This valence electron stuff will also be part of our covalent bonding when we get to the next section as well. So I'm not going to go back over valence electrons. I'll probably mention them, but I've gone over the basic structure of what that all means for this. Hopefully you can remember this when you go on to talk about covalent bonds. So worksheet is either on PowerSchool Learning or it is something that came home in the packet for you. In the reading material, you should have a book at home for this one as well. Again, once you get done with it, you can take a picture of it, send it to me, or scan it and send it to me, however you want to do it. You can email me or put it on PowerSchool Learning in the messages section. All right, enjoy!